I'm pretty confident you could solve this problem very well. 1/2 x plus 1 equals to x minus 1. And as a matter of fact, the answer is going to be x equals to 4. So, and you can see that if we put 4 in here, I've got 1/2 times 4 is 2. 2 plus 1 is 3. And over here, 4 minus 1 is also 3. So there's our answer. And but the point of this problem is that I want to show you the geometry behind of this problem and talk about the geometry of things we're doing in this course, because a lot of this algebra has a geometrical side to it. And now this was not really discovered until the 1600s, close to the mid-1600s. Around 1642, René Descartes found a way of combining geometry with algebra together. He called it analytical geometry. And analytical geometry is this combination of these two subject areas. Basically, Descartes came up with the xy plane, which we sometimes call the Cartesian plane in his honor. And he discovered these relationships between x's and y's algebraically can represent shapes that are geometric. And so this began this linkage of these two areas. So occasionally in this course we'll use geometry in order to understand the algebra, or we may use the algebra in order to understand the geometry. And here I want to show you the geometry behind this problem, because another question I posed in an earlier video was how do you know these problems don't have more than one answer? And I think we haven't really addressed that very well. And so let me show you this. I'm going to, and remember that our answer is x equals 4. I'm going to treat each side as if it's part of a graph. So in other words, I'm going to look at the graph of y equals 1/2 x plus 1 and the graph of y equals x minus 1. So I'm going to try to draw this with some accuracy here. Okay, and each scale mark is a unit, single unit. I know I have to go over to 4. All right, now this graph, y equals 1/2 x plus 1, has a y-intercept of 1, and it has a slope of 1/2, and so the slope of 1/2 means we rise 1 unit and go right 2 units. So if I go up 1 and over 2, I create a second point, and I can connect those dots to form my line. All right, so this is the line. Y equals 1/2 x plus 1. And then the line y equals x minus 1 has a slope of -1, I'm sorry, a y-intercept of -1 down here, and the slope is 1, it's 1 times x, that means there's a 1-to-1 ratio, rise over run. So it goes up like this. So here's a graph of y equals to x minus 1. All right, well, I'm off a little bit. I don't have graph paper up here. I don't have a big ruler I can use, so my graph is a little bit off. But if you did this on graph paper, you're going to find that these, well, as I said, I'm a little bit off because I'm hand drawing this, but that should be exactly at 4, x equals 4. And try it on graph paper, you'll find that's absolutely true. That the intersection point of these two graphs is going to be the answer to this problem. And why is that? Because if we set these equations equal to each other, you know, y equals to that and y equals to that, well, where do they coincide? They coincide when the y values are the same. And so if I equate the y values, it's the same as constructing this equation. And solving that equation is finding where the two lines cross each other, where they coincide. And they coincide when x equals 4 and y equals to 3, I think. 4, 3 is where this point should be if I did this, you know, very accurately. And so that begins to answer one of the questions we have is, you can there be more than one answer to a linear equation? Well, linear equations are equations in which the variables all have an exponent of 1. And the variables don't appear in denominators. There's no square roots or sines or cosines or anything strange. It's just a polynomial equation in which the exponents of the variables are 1. Those are linear. Linear comes from the word line. And so it can be shown, and we may show this in another chapter, that these indeed are lines. And so 2 lines, where can they cross? 2 lines can only intersect in one place, at most. So there can only be one answer to these problems. One answer where the left side and the right side agree with one another. All right, so that hopefully will explain why linear equations have one answer. And because there's a geometry to that which explains it. Now then, what about our problem with no answer to it? And let me show you just a simple one here that's going to be very easy to graph. Suppose you had to solve x plus 1 equal to x plus 2. All right, and there's no answer to this. Because how can 1 more than a number be the same as 2 more than the same number? There's no such number out there that satisfies that. And but if you solve it and subtract x from both sides, you're going to get 1 equals to 2. No answer. Now what's going on with the geometry here? If I look at the graphs of y equals x plus 1 and y equals x plus 2, if you're, real current on your knowledge of graphing, you might say, well, wait a minute, they have the same slope. Each has a slope of 1. And what does it mean to have a slope, same slopes? All right, so y equals x plus 1 will go like this, and y equals x plus 2 will go like that. When they have the same slope, then they run parallel to one another. And so these form parallel lines. This equation then, trying to solve it, is akin to trying to figure out where 2 parallel lines intersect. And they don't, obviously. Being parallel, they run side by side, off to infinity. So they do not intersect. That means there's no common point between them. It means there's no answer. So that's why this problem could not be solved, because in the geometrical manifestation of it, there was no geometry answer. And so the algebra sort of confirms the geometry here and makes it impossible to shows that it's impossible to solve. So anyway, I think this kind of interesting discussion. Now, later on we'll run into problems where there's no solution, but it's for different reasons, because the method we're using contains a small flaw in it. And so we'll see that pretty soon.